Hello everybody, my name is Mike Waltman. I'm the Senior Systems Integration Specialist here at Field Environmental Instruments. Just celebrated my 20th year with the company. And today I'm going to talk to you about the MET1 Instruments family of particulate monitoring devices. That family includes a number of different options and detector technologies. We have nephelometric detectors, particle profiler detectors, and beta attenuation detectors, and we're going to go into detail on each. As you can see on the screen here, a couple of different models under each category to give you a flavor for what they offer. Nephelometers are the most common particulate monitors in the industry. The E-sampler and ES642 shown here are two of our flagship instruments when it comes to perimeter particulate monitoring. What is a nephelometer? A nephelometer is simply an instrument that uses a light source and a photodiode to measure the surface area of particles passing through a known concentration or volume of air. By way of this, the instrument can provide a mass concentration reading, typically in micro or milligrams per cubic meter. These instruments are considered real-time and typically have a response time of about 1 second. When to use a nephelometer? Typically, you're going to use this in your standard construction or remediation applications for perimeter monitoring, work zone monitoring, even in some cases, personal protective monitoring. These are also lower power instruments in comparison to some of the others we'll be talking about. They're able to run on an external DC source like a battery, can be used with a solar panel and battery, and even in some cases can be powered by an internal battery. This diagram shows you how the nephelometer works. As I mentioned earlier, it measures the particle concentrations by using a light source and a photodiode. You can see here in the diagram the way that that light moves through the path of the sample and reflects that light and then is collected and by way of other components internally produces a measurement for you. One thing about nephelometers is they are susceptible to high humidity interference in the readings. So in the MET1 devices, you will always have a standard inlet heater that maintains an inlet humidity of 50% or lower. Some of the things you'll see in this higher humidity concentration environment is swelling of the particles or clumping of the particles. And since it's using the light to reflect off those particles, that will erroneously bias your data high. So that's why it's important to dry the air before it gets to the sample detection chamber. The next category of devices we're going to talk about are very similar to nephelometers, but they're called particle profilers. Typically, a nephelometer is going to provide you with a single cut point or single fraction size of particles, where the particle profilers are going to provide multiple simultaneous particle fraction measurements. For example, the ES405 from MET1 gives you PM1, PM2.5, PM4, and PM10 micron particles simultaneously. They also employ a configurable auto self-test, typically running once an hour, that ensures a very stable baseline for low-level readings that you may encounter in the field. Applications that are suitable for a particle profiler are very similar to those of the nephelometers that we talked about earlier. The difference being with the particle profiler, not only do you get the real-time data, but you also get multiple simultaneous fractions. It's more flexible, just like the nephelometer, and can be run on DC power, typically an external battery, and with the addition of a solar panel, can be run continuously 24/7 for monitoring both day and night. Particle profilers, like the nephelometers that we discussed, use a light scattering detection method, or a light source and a photodiode to be more specific. The addition of size discriminators allows the unit to produce the size selective or multiple simultaneous fractions that we talked about. In addition to that, particle profilers use what's called a sheath air system, which encapsulates the sample stream of air in a sheath of clean air. This does a couple of things. Number one, it keeps the internal optics from being contaminated. It also ensures that in heavy particle-laden flow, none of the particles escape from the sample air. Now, we're going to talk about beta attenuation, which is a very different animal to any of the instruments we talked about so far. The reason for this is the detection method on a beta attenuation unit uses a small amount of radioactive material and a high volume sampling pump. Typically the other instruments we talked about are going to be lower volume, either 1 or 2 liters per minute. On the beta attenuation units, you're typically running around 16.7 liters per minute. Don't worry, even though it has radioactive material on board, it's still safe to handle and transport by way of normal carriers. It uses a carbon-11 source, and it's about 75 microcuries, which is very, very, very minimal. This unit is typically used for longer periods of data averaging or more regulatory type air monitoring. It is not suitable for real-time monitoring, and we'll talk a little bit more about that in a second. The unit also does require AC power to operate continuously. Because of the high volume pump, the unit is much more power hungry than its smaller siblings like the ES405, the E-sampler, and the ES642 we've already discussed. This is a diagram of how the beta attenuation system works. As you can see, there's a lot more going on here, including the radioactive source, a nozzle assembly, filter tape, which is what actually accumulates the material over time, and the detector that sits underneath it. The accumulation of that material on the tape is what attenuates the signal from the beta source, hence the name Beta Attenuation Monitor, or BAM for short. Here's some examples of what the unit looks like in the field. You can see in the photos here the nozzle assembly indicated by the orange arrow. That's where your radioactive source sits. Just below that in the silver block is your detector, and between the two is your tape media. On the right here, you can see that the tape media collects the material in a circle or dot formation on the tape, and that is what attenuates the signal. The reason these are not suitable for real-time applications is because you need to allow time for that material to collect on the tape in order to cleanly attenuate the signal from the source to the detector. The most accurate response on this instrument is 1 reading per hour. You can see in the chart here, the blue line represents the real-time data, which is all over the place. The orange line is the 1-hour average of that data and is typically the data that's going to be used, and in a lot of cases will be used to aggregate into a 24-hour average. Again, this is not for real-time operation, but it is used for near FRM, Federal Reference Method, or FEM, Federal Equivalency Method, results, although it carries neither of those designations officially for the EBAM specifically. Most recently, Field Environmental Instruments supported the contractors on the ground in Kula. That's in Maui, Hawaii, for the wildfire response. You can see some photos here of the EBAMs deployed in the field. And even in the middle picture, you'll notice that there's a sonic weather station attached to the unit. So one of the nice features of the EBAM is that you can integrate meteorological data right into your data stream with your particulate readings. The best time to use a beta attenuation monitor is when you need higher accuracy for longer term exposure monitoring. Because of the collection system on the tape that we talked about, the unit is less susceptible to humidity particle effects, although it does still employ an inlet heater that allows it to dry that air before it reaches the tape. Typically somewhere around 50% humidity is where that heater will kick on and will cycle off as the humidity dries out. It's near FRM or FEM quality results, but as I mentioned before, it is not designated as either, specifically on the EBAM model. You'll remember on one of my first slides, I had the EBAM Plus, which is a newer model from Met1 Instruments. That does carry an FEM designation for PM 2.5. Some of the other things from Met1 that are nice and we've recently brought into the rental inventory here at Field Environmental is the Swift 6.0 and the Swift 25.0 field calibration instruments. These allow you to quickly and easily field audit any of the devices that we talked about today with a very simple user interface and a very small, compact instrument. I'd like to thank everybody for being here today. We greatly appreciate your attendance at the Field Environmental 8-hour HAZWOPER refresher course, and I hope you had an opportunity to learn something from my presentation today. Don't forget, reach out to your local FEI representative if you have any further questions or any interest in renting any of the instruments we talked about here today, or for any other equipment rental needs. Thank you, and now back to your training.